Now let's go back and look at our heart rate data again and solve our next problem, which is how many laps up and down the stairs did we do here? If you look at this data, you'll see it's very jagged. There are a lot of fluctuations up and down. This jaggedness comes from going up and down the stairs. As I go up the stairs, my heart rate increases. When I'm coming back down, there's a little bit of rest and my heart rate goes back down a little. This pattern means that each peak corresponds to one trip up the stairs. If I wanted to know how many times I went up the stairs, I could just count the peaks to have a very good estimate. We could try to count these peaks by hand, but that seems like a bad idea. For one thing, counting how many peaks there are in this graph would be quite tedious and error-prone. If we only needed to do this task once, it might still be faster than writing code. However, if I want to count my peaks for each workout, the time savings of writing code will quickly add up. Once the code is written and tested, we can just run it on any input data and get the results with very little extra work. You will find that this situation can be quite common with a lot of problems. If you just wanted to do it one time, it may not seem worth developing the code. But any other times you need to solve the same problem would amortize the cost of developing that code, and quickly you would find that having an automatic solution saves you significant time. So, let's write a program to count peaks in the heart rate data. Our input is going to be a list of heart rate data, one value each second, and our output is going to be how many peaks there are in the data. As always, we want to start with step 1. This situation is another example of having too much data to work an example by hand. We should start with a much smaller example. We could just look at this and say, okay, the answer is 2, but we need to do that in a more step-by-step fashion to be able to generalize the algorithm. We can start by keeping track of how many peaks we have seen, which starts with 0. Then look at the first element of the data. Is this a peak? No. Likewise, the next element is not a peak. However, the next element is a peak. As we go back down, the next couple elements are not peaks either, nor are the ones going back up here. But when we get to the top, we've found our second peak at 164. Then we have 2 more that are not peaks as we go back down, so now we have come up with an answer of 2 in a step-by-step fashion. Now we are ready for you to do step 2 and 3 of the 7 steps. For the moment, we are not going to try to work out the specifics of, is it a peak? We will abstract that out for now. We're going to assume that we can just ask the question, is there a peak at this particular place, and answer it correctly. Then later, we will solve the programming problem of figuring out if we have a peak at a particular place.